In this video, I'm going to show you how to find the limit of rational functions as x approaches infinity. Here we have the limit of x squared plus 4x minus 4 over 2x squared plus x minus 1 as x approaches infinity. So how do we do this? Well, first is we need to plug in our value for x. So in this case, they want us to use infinity for x. So when I do that, I'm going to have infinity squared plus 4 times infinity minus 4 over 2 times infinity squared plus infinity minus 1. So the numerator, we're going to have infinity squared, which is infinity, plus 4 times infinity, which is infinity minus 4. So a big infinity plus another big infinity minus a little bit of numbers will still produce infinity. So for the numerator, we'll get infinity. The denominator, we're going to have infinity squared times 2, which is still infinity, plus infinity minus 1. Well, that's still going to be infinity. Okay, so in this case, we have infinity over infinity. So here we have what's called an indeterminate form. So indeterminate form. So what that means is if we have a form where it says infinity over infinity or some form like this, that means we need to do a little bit more work. Okay, so how would we solve this? Well, what I need to do is I need to look in the denominator. As I look in the denominator, I need to look at the term with the highest power. So in this case, that would be x squared. And I will need to divide each of the terms by the highest power. So in this case, I'm going to put my scratch up here. And I'll have x squared plus 4x minus 4 over 2x squared plus x minus 1. So again, the greatest term or the highest power and the greatest in the denominator is x squared. So I'm going to divide everything by x squared. So in this case, I have x squared over x squared plus 4x over x squared minus 4 over x squared. The denominator is going to be 2x squared over x squared plus x over x squared minus 1 over x squared. Okay, so now I simplify a little bit. So x squared over x squared, well, that's just going to give me 1. Okay, and then I have 4x over x squared, so that's going to give me 4 over x minus 4 over x squared. Sorry, that's a plus there. In the denominator, again, this x we're going to cancel. I have 2 plus, and then one of the x's are going to cancel. That gives me 1 over x, and then minus 1 over x squared. Okay. So that's what I'm going to have for this next step here. So actually, I'm going to write down here the limit as x approaches infinity, and I'll have that 1 plus 4 over x minus 4 over x squared divided by 2 plus 1 over x minus 1 over x squared. So I just need now, once I have this, once I have it down to this part, broken down to this part, I'm going to plug in my value for x. And when I do that, that limit symbol is going to drop. So I'll have 1 plus 4 over infinity minus 4 over infinity square divided by 2 plus 1 over infinity minus 1 over infinity square. Okay. So here I have 1, and then 4 divided by infinity, that's just going to give me 0, right? So you have a small minute number divided by infinity, it's going to go to 0. Same thing here, this time it's infinity squared. So that's actually going to go faster. So this is actually going to go to 0 as well. This one's 1 divided by infinity, which that will go to 0, and then 1 over infinity square, again, that's just going to go to 0 as well. So I have 1 plus 0 plus, minus 0, and I have 2 plus 0 minus 0. So 1 plus 0 minus 0 is just 1. And then 2 plus 0 minus 0 is just going to give me 2. So the limit of this function here, the limit of x squared plus 4x minus 4 divided by 2x plus x minus 1 as x approaches infinity is equal to 1/2.